Anyone can build a spider robot for Arduino. Today we're going to check out the Sunfounder Crawling Quadruped Robot Kit for Arduino. Stick around and check it out. If you found the information in this video to be helpful, don't forget to like the video by clicking the thumbs up, and also don't forget to follow the channel so that you can catch our upcoming videos. Hey guys, welcome back to Bee Monster Laboratory. The reason I said that anyone can build a robot, or more specifically anyone can build a spider robot, is because I did. If I can do it, 99.99% of the people watching are capable of the same thing. With that said, let's check it out. The first thing you'll want to do is go ahead and get all your pieces together, and then you want to remove the backing from the acrylic to make your robot nice and shiny and black. And for that I'm using a tool with a flat end and a pointy end in case I need that. You can use a flat edge tool to get it started, to peel it off, or if you have strong fingernails you can scrape it off by hand too as well. Either way is fine. So your next step would be to come here to the Sunfounder.com website. You go to tutorials and you'd come down here to Robot Kit, and I have the quadruped crawling robot kit for Arduino. So you'd click on that, then you would download the cd.zip and maybe the PDF if you speak German, I don't know. So you download that. So your next step would be to come here to the Arduino.cc website, and from here you will download the Arduino IDE. The IDE stands for Integrated Development Environment. If you're unsure how to download the Arduino IDE file and set that up, I did previously make a video on how to do that. I will link it in the description below and also embedded in the video. So far you've downloaded the software from the Sunfounder website for the quadruped robot. You've downloaded and installed the Arduino IDE from their website. You've installed the appropriate driver for your computer. Now you would go to Sketch, come down here to Include Library, Add Zip Library, and install the zip files that were in your CD folder. After you've installed the two zip files from your CD folder, the Flexi Timer 2 and the RF24 zip file, you should be able to go to Sketch, Include Library, scroll down to the bottom here, and they would be here under Contributed Libraries, the Flexi Timer 2 and the RF24. At this point we're going to check the servo motors. So you want to take your rocker arm. You want to take the one maybe with 3 holes in it here, and you want to place it on your servo motor, and you want to, there's one side that has grooves in it, fits right over top of the white tab here. So you want to put that on there. Then you want to get your battery pack. Your batteries should be lithium ion 18650. That's what I've got here. You shouldn't put your batteries in before you load it onto your board, because those leads could touch and then you get a spark. So don't do it this way. After you've done that, we're going to connect the control board to the PC. Plug that in right there. At this point, you want to go back to your Arduino IDE, and you go to File, go to Open. You want to go to Servo folder, Servo, and then it might say servo.ino, or just servo like this. You want to open that. At this point, to avoid frustration, you want to go to Tools. You want to make sure it says Arduino Nano. If you've been using the Mega 2560 or any other board, you want to select the Arduino Nano. And also, very important, you want to select the correct port. So for me, it's COM6. Nothing will work unless those two are correctly selected. At this point, I'm going to connect my servo motor. You could do it before, or you could do it now. I'm going to do it now at this point. It says right here, ground is on the left, signal is on the right. The brown is ground. So you want to, brown is going to be on the outside, the brown wire. So that's how you attach it. I'm going to turn that on. Now I'm going to go over here to my software, and I'm going to click on Upload. There we go. And you want to check every one of them like this. Probably the best idea. Now I've removed the arm from that servo. I'm going to put it on another one. And I'm going to make sure it works properly. I turn the battery off. I put my pin in with the brown wire on the outside where it says ground right here. I come back over here to my software. Click on Upload. Oh, then I turn my battery back on. So that one works. And I'm going to do that for all of them. And for each one of these, you want to remove the power from your computer just to make sure that the servos are working. Do that for each one of them, and that's how you test it. For the remote control assembly, I did use the ribbon, so here I cut it in 4 pieces. I also left the backing on the acrylic because you can't see it anyway, and it didn't really matter to me. Also, once you have it assembled and you have your batteries in, and if it doesn't work, you may have to slide your battery back and forth to get it to contact inside the battery case, because that is a pretty tight fit. You turn it on. It should power up just like that. I want to go to open. And I want to back out here and I want to go to the NRF 24101 file. And then go to transmit and then open that. Under transmit, you open that up and then you hit upload. It'll upload it to your controller. It says that I got an error. I bet you I know what it is. You make sure that says Arduino Nano. For some reason mine has to always have it on the old bootloader at Mega 328P old bootlegger or bootloader, and then COM4. Now I'll try it again, and it worked correctly. Done uploading. So now I will turn my battery pack on and I will plug this into the servo board. I will go to File Open, go from Transmit to Receive. Then I will go up here to Upload. Oh, you can't see it. So basically I went from Transmit. I'm on the transmit here. I go to open, and then you just go to the receive part. You just go to the receive folder and then open that. Upload it to your board. Done uploading. So after I've loaded the receive file here onto my servo board, I can open up under Tools, go to Serial Monitor, and as I'm moving the control stick around, it should come up with different values, as you can see, and I'll make that bigger for you. And now that we know the wireless part is working, we can turn off the battery and then unplug the board. When you're done with that, you're going to want to put these plates on the acrylic. They fit on there just like that. You want to line up the holes. Then just screw in every little screw. Match the servo with the thigh. So the next step is to combine these two guys. So I'm done combining these two servo motors to form the joint of the leg, and you should have 4 of these. Open up your Arduino file and go to Preferences and come down here to Display Line Numbers. Make sure that's checked. Everything looks okay. Go up here to Open, go to Crawler, open. Now it's time to calibrate the legs using the sheet that was included in your package. I get the X and Y, but I'm still not sure about the Z, but that's something I can play with. I know the Z corresponds with the height of the leg, so I'll just play around with that. And we go back to our software here, and we go to Open. Want to go to Crawler? Is that what we're in? No, we're in Stepper. Crawler. We come down to line 33 to adjust. First of all, let's put the slashes back here for install. We already did that. Now we want to adjust. And now we come down here, and these numbers are going to correspond with what we measured and wrote down here. So I got 120, 68, 30, that seems awfully far off, but whatever. 111, 83, 35, 111, 83, 30, 111, 78, 30, and then we I just wanted to include this in the end. I actually put in the wrong value for X value and for the fourth leg, and when I uploaded it, it didn't work. I don't know if that had anything to do with it not working, but when I went back in to check, I noticed that it said 11 instead of 111, so I did fix that. So here I had to show you a few things that I had to fix before I actually got the robot to work. When I first powered it up, I noticed that the robot's belly was pretty low to the table here. So what I did was I shut it off, I connected the board back to the software, and I went in and that Y value that was 30, I doubled it to 60, and it lifted him off the table some more. It's fine. I still may go in later on and do some adjustments with those numbers just to see how it changes the orientation of the body and the orientation of the legs. So that's something I'll do in the future. Well, this has been an excellent purchase. It was my first Arduino robot kit that I purchased, and it was a great educational experience for me, as it would be for anyone, I believe. There are a couple things that I'm curious about. Is later on in this video you'll see that his legs bend underneath the body, which is quite interesting to me. I'm not sure why. Maybe it needs to be recalibrated. Maybe he doesn't like to walk on carpet. I don't know. You'll see that later on in the video. I'm also wondering if it's normal for the joints to become separated, because after a while of playing with this thing, you have to squeeze those joints there where the servo motors are to make the connection stronger. So it's just a little screw holding it together there. So I'm just curious if you're familiar with these robots and you know the answer. Go ahead and let me know in the comments below. I have quite a bit to learn about these type of robots, and I'm already looking for my next one. So other than that, I mean, it's an excellent experience. Highly recommend it to anybody who's interested in learning how to use Arduino, learning to build robots. I give it an A+. I just loaded the dance software. Let's turn on the robot here. I don't know what's up with that leg right there. Look at that. That's weird. Well, I think I've shared just about everything. So, as always, thank you for watching, and I'll catch you in the next video.